So right here you see a list of valence electrons with their Lewis dot symbols. These valence electrons and elements are placed in order by the periodic table. It makes it very simple, very easy. So this is something maybe you could jot down to understand. But what you see here is in column 1A, hydrogen, lithium, sodium, and potassium, all there with one dot representing one valence electron. Very easy concept to remember. Valence electron, dot. They equal each other. 2A, same thing. You have all those elements have two dots on either side. 3A have three dots dispersed around the element symbol. 4A, you have four dots separated, dispersed around the element symbol. 5A, 6A, 7A, and 8A follow this same pattern. So here's where you can put that little chart into place with Lewis structures without the dots, just the bonds. Okay, so right there you see the chemical formula for HNO3, which means you have one hydrogen, one nitrogen, and three oxygens. On the atomic sequence, you see just where they're going to be placed, okay? And what you see here is that there is 5 total bonds, and that leaves room for just 14 more electrons to be dispersed. Now, here on this structure, you see only the lines which represent bonds. So here, where there's a double bond of oxygen to nitrogen, there's also just a single bond of oxygen to nitrogen, because when you have an oxygen bond with a nitrogen bond, you must have 8 valence electrons on each element. That's the key to every Lewis dot structure. So for each line represents 2 electrons. You move down to the graph 6 down here, and you see where it actually happens. So if you count 1, 2, 3, 4 oxygen valence electrons, but you need 8. So therefore, you need to have a double bond to make that satisfied. But you see over here on the right side of the nitrogen, this oxygen has 1, 2, 3, 4, 5, 6 lone pairs. So therefore, it only needs another 2 to make it a complete set of 8. Now, on the bottom of this dot structure, it gets a little more tricky, because you see oxygen have 1, 2, 3, 4 lone pairs of electrons, and you'd figure, hey, let's just throw a double bond on there and that will work. But you have to include that last hydrogen into the formula. So instead of throwing a double bond on there, you will put a single bond on either side of that oxygen. Okay, now, I thought this was a very good slide to further demonstrate how to use Lewis dot structures. So with this slideshow, it's very detailed, very organized, and less jumbly than the last one. First thing you see is the compound ClO2-. It gives it skeletal structure, and skeletal structure is basically, it's the element symbols without any dots or lines. So it's just showing how many chlorines and how many oxygens there are in the formula. That's it. It's just separated. The count electrons, they do theirs quite confusing, but basically the rundown is 7 valence electrons in chlorine and 6 valence electrons in oxygen. Now, seeing as we have that minus that is still there, we have to add one because minus represents an added electron. When you do all the math and put it together, 7 times 1 is 7, obviously, 6 times 2 is 12, and that there equals 19. You add one more, and you've got 20. Now, moving down to the electron pairs in bonds, you see that they have done a little pre-octet. All they have there is the single bonds represented. And the math formula is 20 total valence electrons, 4 electrons used in the bonds, is equal to 16, which is how many electrons we have remaining. Now, once we're done with the bonds, let's move on to the periphery atoms, where we can get rid of some of those leftover electrons. So the periphery atoms are the atoms that aren't in the middle, which are just the 2 oxygens. So to complete their octet, you put 6 more on the outside to equal 8. Since we have 16 total left over to use, we just have to, then we use the 12, 6 on either side. We have 4 now for the remaining part of the box. So the remaining electrons will have to go on the chlorine, and that works out perfectly because the chlorine needed those 2 more electrons. Hence the reason that it adds another one and becomes a polyatomic ion. You see, if it did not have that extra electron, there would not be enough, and what you would see is a chlorine with only 3 around it. 3 red ones, that is. So those remaining 4 minus the 4 equals 0, and we have used all of our valence electrons. Now, this final structure is something that will confuse you on a test, will confuse you on anything, just because of those silly brackets. Now, the reason you have to include those brackets around it, and then that negative charge on the outside, is because it represents the idea that it is a polyatomic ion. If we did not put that there, then it would be simply incomplete.